204, 205? Awesome. I'm surprised there are so many people here, like the second to the last session of the whole thing. Thank you. You're great. Yes, I love it. Okay, awesome. Awesome. Welcome, everybody. So today I'm going to talk about getting experienced internal developers started on open source work and the kind of typical problems that these senior developers run into. Before I really dive in, this big QR code, this goes to a copy of the slides. In the speaker notes of the slides is an approximate transcription of this talk. Secretly, I'm like kind of bad at public speaking. So the speaker notes are like almost exactly what I'm gonna say. If you can't hear Netflix without the subtitles like me, probably it's a good idea. And then the slides are also comments open to anybody from the public. So if you have a question that you don't want to ask out loud or that you only think of tomorrow or whatever, you can just drop a comment on the slide. Me and the slide co-author Yvonne will both see it and we'll reply as soon as we can. So this was up for a couple minutes. Does anybody still, everybody's got a picture of it? Who needs it? Okay. If I see people leaning in to take pictures of the slides, I'm going to be very unhappy. Okay, so my coworker Yvonne and I developed this talk together. He's not here, he's on vacation, so it's just me. But I'm gonna introduce him anyways because he was really integral to writing this stuff. So Yvonne is a maintainer on the JGit project. He's got a background in open source work. Before he came to Google, before he started working on JGit, he was working on the GNOME project, and yeah, whatever, GNOME, GNOME, whatever. And so for the last 7 years, he's been at Google working on a team building an internal project that's based on this public JGit code. That's what we use for all of our proprietary Git hosting. I'm Emily. I'm not on vacation. I have a background in open source software, but it's been really mixed in with my internal work for quite some time. So when I started at Google, very quickly I became a co-maintainer of the IPMI subsystem on OpenBMC. This is like an embedded Linux kind of thing. If anybody knows what it is, like high fives. And for the last 5 years or so, I've been working on the Git Upstream project. And then later I was leading a team that was working on the Git Upstream project. And then as of a couple months ago, I'm not doing that anymore. I moved to a new role and I'm managing the relationship between the Google Source Control org, which the Git team was a part of, and all of the open source projects that we either ship, depend on, contribute to, any of this stuff. There's like 6 and growing. So what makes Yvonne and I qualified to talk about transitioning from internal code to open source code when both of us have these like huge careers in just open source, right? So Yvonne works on JGit, like I said. This is an open source project. This acts as the backbone for Google's proprietary internal Git hosting and review services. So we also have review based on Gerrit, which is based on JGit. I worked on Git, which is used directly by a lot of developers at Google. It's also wrapped up in other tools at Google. A lot of Android development happens with a tool called Repo, which just directly uses Git in some inventive ways. And so beyond developers at their workstations, also we have a lot of tools inside of Google that are communicating using the Git protocol or using the Git file format, and both of those are defined in this first-party Git project, even if we might use them through another re-implementation library like JGit or like GitOxide or libgit2 or whatever. So both of us are in this position where we're experts on an open source code base, but everybody that we work with is just trying to get their stuff done in a proprietary environment. They're just trying to get their OKRs in, And so both of us have seen a lot of these highly skilled colleagues that we work with. Google hires a lot of really smart people, and we see our colleagues get intimidated when they're told to go and submit their changes upstream. As far as dev workflows go, we actually have it really good inside of Google. So we have one bug tracker, sort of. We have a monorepo for all of our code, sort of. We have one build system, sort of. We have one tool for submitting changes, mostly. It's really homogeneous. It's really easy to move around. Not that like the code is really simple from project to project, but you're gonna have a lot of tooling in common. There's kind of a common language here. So when you send a change, you know the reviewer. You talked about your change at lunch. You stood at a whiteboard together. Maybe you worked on a design doc together, or you saw the same bug in triage or something. And for many, many Googlers, especially in our org where people are generally like 5+ years of tenure. This is the only environment that they know, maybe from college, or maybe it's just the environment they've been using for so long that they're not really like thinking of anything else. But when we go upstream, it's like we went to the jungle, right? So even if the code is hosted in the same place, like in GitHub or in GitLab, processes are not necessarily going to be the same between projects. And sometimes those processes are going to be made really explicit and documented, especially in larger projects that have dealt with this whole scaling to hundreds or thousands of developers thing. But more often, we find that these projects are implicit, and that makes open source really challenging to navigate. So we see a lot of our coworkers get culture shock. And by the way, Yvonne asked me to tell you all that he had culture shock in the opposite direction when he came to Google. He wasn't used to any of our monorepo stuff. He couldn't find his edits. He didn't know how to make branches. He didn't know all kinds of stuff. So the difference between this really strict, well-lit path that Google has and what the rest of the world does, it cuts both ways. It's bad for people learning both directions. And there's a whole internal meme about it. But yeah, so it's a big deal, right? So when you're joining a new project, there's like two kinds of things that you have to learn on this new project. So first, you have to learn how the code works. How's it architected? How do we change it? Like, this kind of technical stuff. But I'm actually not going to talk all that much about the technical stuff, because the audience for this talk is people who already know what they're doing, technically speaking. There's lots of really good talks about cutting your teeth in programming by writing open source software. This is not that talk. Go watch one of those, they're great. What we find actually is that our experienced engineers are much more likely to struggle with the people and the processes. So open source communities will organize themselves very differently from how companies organize themselves, and they usually also organize themselves very differently from other open source projects too. This categorization, it's not really a firm, A or B, black or white, technical or non-technical. Code is written by humans, sometimes, most of the time. So all code at least has a little bit of a social construct involved. So one example, right? Can you tell me, is it a technical or a social problem, the style guide? What coding style we use? Is that technical? Is it social? Do we have flame wars about white space? It's both, right? But everybody has the same goal in mind. We're trying to produce software that's good. So there have to be some rules of thumb, some stuff in common in how we deal with this stuff. 1 second. So actually, some of the really technical problems are even more social than they appear at first. So even though an experienced developer knows what they're doing technically, the norms of the project are still going to be new. They know already how to write and test and review and release their code, but they don't necessarily know where those things are done or what tools are used by this project. And if these things aren't documented, which they should be, if there are maintainers in here, please document this stuff, then our new contributor is going to have to find somebody to ask. And writing this documentation, by the way, is also a really good way to get new people to learn how to contribute to a new project. I actually gave a talk at this conference some years ago about this, about onboarding to new projects by writing documentation. I thought it was really good. I gave it, so I'm biased, but you can find it at the link here in the slides, which everybody has from the QR code. So just understand that not everything is documentable. Not every technical thing can or should be documented. If the maintainer were to write down every single detail of how you're going to contribute, then new contributors are going to read this huge book about what they need to do before they even send one bug fix. It's way too much for a brand new contributor, and also that book is going to be stale by next week. So Yvonne has had a lot of comments from people trying to contribute to the JGit project, saying why did you tell me to do this? Or where is that written down? And while it helps to have a reference that you can point people to, you're not going to be able to cover everything. So the Git project, this is also an example, has this coding guidelines doc, and that makes an effort to cover really everything that you would possibly need to do to your patch before you can submit it. I checked, this would have been last week that I checked. It's 827 lines. They're very dense 827 lines. It's a good reference text if you want to point to somebody to one thing in there, but like it's a lot for a new contributor to try and read and verify before they send their change the first time. And these projects aren't really going to be necessarily self-consistent, or sometimes they don't even make sense. So sometimes the style that a project uses is maintained because years ago somebody did it that way, we left it, fine. Or maybe we did decide to change it and we got like halfway through changing it and we never really finished the effort. So the style that your code should use, it's not really clear either, right? And some of these things are also unwritten just because the maintainer believes firmly that it's common sense and everybody should just know. Yeah, right, like who knows people like that, right? So JGit, for example, tries to minimize external dependencies. They don't like adding new dependencies. And this isn't written down anywhere. JGit also likes to put their non-public APIs into this special like .internal package. And this is not written down anywhere. But these seem like common sense directives. You know, they're not written down, but they're not necessarily common to other projects. So you're still going to get feedback from your code. You're not going to be able to get everything right the first time. You're not going to get all the conventions the first time, and that's okay. That's part of the whole deal, right? So okay, so we read the documentation where there was documentation. We trusted our senior experience. We trusted our instincts. We have a series. It passes tests. The style seems good. We're going to do code review. But instead of doing code review with the person that you just had lunch with, you're going to do code review with a stranger from the internet. And this is where no amount of documentation is going to save you as a new contributor. The docs are like reading a travel guidebook, right? To help you plan your trip, you decide, I want to see this stuff. I got to make sure to do this stuff. But now you got off the plane, your feet are on the ground. You're like just trying to like stick with the local customs and like survive, right? So this is where we are. And remember that regardless of the people in the medium, the point of the code review is always, always, always to make maintainable, correct code. And experienced developers, we assume, are familiar with code review. We know that it's for correct code. We know it's not for whatever this stuff is, right? But when we send our precious code to be critiqued by strangers, we can forget. It's easy to forget. So it helps to, step back a little, give yourself a reminder about the common purpose of code review, and then it helps to put yourself into the reviewer's shoes. So your maintainer reads a lot of code. So think about previous maintainers that you've had and previous leads that you've had. How much code did they get to write compared to how much code you get to write, right? They're like maybe a little jealous. And maintainers are basically the open source equivalent of a tech lead. On really busy projects, they're going to write a lot more code. They're going to review a lot more code than they're writing. So they've seen some stuff, and they've seen how that stuff works out in the long term. So when they make a suggestion, you have to keep in mind that they have a reason. There's a convention. The convention's there for a reason. Even like weird and dated conventions, like maybe it uses a really weird formatting choice that you're not familiar with. It probably served a purpose once. Like maybe it was useful before everybody used an IDE or IntelliSense or something. And maybe now it doesn't serve a practical purpose to keep it around, but the custom is already there, and it's really not worth the churn to like restyle the whole project. Plus, this code review, your first code review, it's going to be the very first time that these maintainers are working with you. The maintainer doesn't know what your company's coding interview is like. They don't know how your last performance review went. They don't know how many points you signed up for this sprint, right? All they know is the code that you sent them and the context that you sent along with it. And so as we've established, your first communication is not going to be perfect, but it shouldn't be shoddy, right? You should be trying. Your goals are not going to be the same as your reviewer's goals. When you work on internal code, your coworker knows about the change that you're trying to make. They know and they trust you as a developer. They've seen your work before. And it's really easy to just like keep that mindset. You go into the open source world, you're like, yeah, I'm hot. I know what I'm doing. My code is so good. It's going to speak for itself. Like, these guys are lucky to have me. But that's not how it works in practice. If you're a maintainer and you had one patch from Random McLastname and one patch from Linus Torvalds, which one are you going to look at? And which one are you going to trust to know what they're doing, right? Are you going to take a massive refactor from somebody that you're unfamiliar with? Or are you going to take it from somebody who's been in the project for over a year? They're going to stay for another year. They're here for the long term. People say that that no one on the internet knows you're a dog, right? Who's heard this? For better or worse, maintainers will use the signals that are available to them to decide how to prioritize your code. They can see your name and your email. Do they recognize you? Do they know you from a programming blog? Is your contribution from a company email? Is it from a university email? Is it from Hotmail for some reason? Like, there's a lot of room actually here for bias, which sucks. They have, we're human brains. Like, we have human brains. With limited information, humans are gonna make lots of guesses about the experience level, the origin, the motivation behind a change, all of this stuff. This is their first impression, and continuing to contribute well-written, well-explained code over time is actually gonna revise that assumption. And these biases creep in because there's such a scarcity of information that's available to human brains. The more useful context that you provide before and during your code review, and the better that you conduct yourself during that code review, the higher other project members' opinion of your work is gonna be. And by context, I mean, like, why and how are we solving this problem? So in an internal environment, how do you usually build that context with your coworkers? Maybe you go to the same sprint planning meeting. Maybe you do a bug scrub together. If you're stuck, maybe you grab a whiteboard together and hash out the solution. Or maybe you do some pair programming, figure it out. But you're around your coworkers all the time. You have so much shared context. You guys all know the same things. And you usually are working in the same time or the same place or whatever. Like you're present with each other a lot. But your co-contributors upstream, you're gonna have a harder time building this shared context with. So while most projects do have a bug tracker or a bug queue or something, the bugs there might not be well triaged or well scrubbed. Some projects do not have bug trackers. Sprints, quarterly planning, road mapping, all of this stuff, it's really hard to do when projects are being run out of people's spare time. Like if you had to, if you have 2 hours in the evening to do hobby work, are you gonna write code or are you gonna do sprint planning? Like, come on, right? So these synchronous, high bandwidth communication techniques like whiteboarding, pair programming, all of this stuff, it's really hard to do with contributors. Maybe they live on a different continent than you. Maybe they're, they're hobbyists. And when they do this in the evening, they can't take a video call to do whiteboarding because their kid is asleep, So this is part of why open source projects care so much about commit messages. In a low context environment, these commit messages are that's all you get. Without the commit message, your maintainer sees your solution, but they don't see your problem. So I'm gonna put this in really big letters. This is really important. You need to write great commit messages in open source. The commit message is gonna help reviewers understand your change. It's gonna demonstrate that you've really thought about the problem and that you've invested time and therefore your reviewers can also invest time. And it's also gonna get your change more attention, which is gonna directly translate to a faster and more thoughtful review process. By the way, I do have a direct link to the slides in the thing. So if you want, you can just pull up the slide. Yeah, you're fine. Okay, so there are lots of guides out here about how to write fantastic commit messages for open source. So I'm gonna just show one to demonstrate what I mean. I'm not gonna dive into it. This is homework, it's linked in the slides. You can really take a look at it. You can read some other guides about writing good commit messages. Go online, do some reading, think critically about what you're reading, think about the advice that you're seeing from the perspective of the maintainer. Why is each feature of a commit message important? Not gonna dive into it, but when I say great commit message, I mean like a freaking novel. Okay, so one of the biggest barriers that we see with our colleagues who wanna contribute to upstream is fear, the fear of doing work in public. And the first thing that I will say is that it gets easier with practice. Showing your code to the world, it's a skill, just like anything else. You practice, you get better at it. I have social anxiety, seriously. And I got past that social anxiety and became a happy member of actually multiple open source projects. I promise that you can too, I promise. So how, right? So you can do some independent prep if you want. This is kind of time consuming, but it does work. So this consists of looking at other people's reviews and getting an idea of what you have to expect. So where people usually go wrong, where reviewers are most likely, if there's one reviewer who always kind of seems grumpy, if they're prickly towards everybody, you don't have to take their prickly as an insult to you. But actually, I think the tool that works a lot better is pre-review. So pre-review, this is a really good reason to find a mentor. I'm going to talk about that in a second. But basically, you're asking the project for pre-review, or if you don't find a specific mentor, you can also ask the project for maybe I have a patch, I don't know if it's good enough, can somebody just take a look at it before I send it? I just want one person to look at my thing first. You will probably get assistance with that. That's fine, right? Contributing upstream, it's not an exam. There's not an expectation that you're going to get your change perfect the first time. It's OK. The goal of the pre-review step is to get your patch ready to send to the mailing list without breaking style or communication norms. The purpose of the pre-review is not to guarantee submission of the patch. The purpose of the pre-review is to guarantee your dignity. This is just how you keep from being embarrassed on the internet. Wait, I was just in a talk on Monday about how to not be cringe, or the fear of cringe. This is how you get past the fear of cringe, right? Somebody is telling you, yeah, you can send it, it's not right, but it's not cringe, right? That's the goal here. So your goal is just to get the patch into the right shape where it doesn't look unusual to the project, and then we can iterate on the contents of that patch once it's out in public. So who do we ask for the pre-review from? Like I said, you could ask on the project. Sometimes it's easier to do it with somebody who you have kind of an ongoing relationship with. So you want to find somebody who's already familiar with that project's implicit norms, and you want to ask them for advice. If there's somebody on your team who's already been working on the project longer than you, that's obviously, yes, ask them. They know you, they know the project, perfect. If not, you might want to ask your open source programs office. They maybe know somebody else in the company who's been working on this project, or maybe on a similar project in the same foundation, or same tooling or something, and that person can give you advice. You can also ask the community. This question might be surprising to some communities if they don't already have an explicit mentorship program. So you might not want to say, I need a mentor. You might want to say, phrase the request in terms of specific things that you want help with, rather than just, mentor, please. So what are those specific things? Pre-review, like I said, this is a really big one. Your mentor also can tell you about implicit expectations that the project has, and when you're breaking those implicit expectations. These are a couple really basic things that are super helpful. Another great thing that mentors can do is actually give you a second opinion on communication that maybe you don't think went well. Textual communication is so hard for humans. It's really common for us to perceive things when it's just in plain text, it's really common for us to perceive things as rude or as, offensive or something. And that's not usually the way that they were intended. So getting a second read on a conversation that made you uncomfortable can be really, really helpful. I've done that so many times. I just want to say there's a talk that goes a little bit more into these the difficulty of text-based communications in open communities by Megan Bird-Sanicki, who is or was a Googler, and it's linked in the slides, in the speaker notes, and in the resources at the end of the slides. I highly recommend that talk. It's awesome. So, okay. You have your code out for public review, right? When you need a review at work, it's not a problem. What do you do when you need a review at work, right? You hit send. You go, hey, can you review my code, right? You turn to one side, you ask your neighbor. Or maybe you ping your team chat, or you already are working on the project with somebody, you have a designated reviewer. In open source, this is a lot less typical. People will often review based on whether they think your change sounds interesting or useful. So it's a really good thing that we wrote that great commit message, right? You're halfway there. In open source, if your change is stalling, you can't really tell your manager that nobody's reviewing your stuff. You're the one who's responsible for getting somebody to take a look at it. You have to get the attention of the maintainer or of the committer or whatever. You have to convince them, why should they care? Why is it relevant to the project? Maybe the change is in a part of the code base that this maintainer is a little less familiar with. Why should they make the effort to familiarize themselves and get into it? Reviews often have inertia, so changes that already have action will get more action. So if your mentor is working on the same project as you, you can also ask your mentor for an initial public review, and that can help get the conversation flowing. And that should be substantial, right? Don't ask your reviewer to just rubber stamp. That's not going to do anything. But it can be a good tool. So some projects have something kind of like this Linux kernel owners file. For other projects, you can usually check Git blame and see like people who touched the code where you're looking before. And those people are usually pretty interested in what you're trying to do. So this technique can feel a little mercenary, but you're probably not the only person struggling to find reviewers if you're not getting attention on your commit. Probably other people are the same. You could probably trade reviews with one of those contributors, right? You could review their patch, and then you could say, hey, if you have a minute, mine also doesn't have a review. Maybe you want to take a look. And if none of this stuff is working, if you really can't get anybody to look at it, you tried everything, you can ask the maintainer, like, why is this patch so unappealing? Like, tell me, what did I do wrong? Be prepared. Your maintainer's going to be honest. They're really busy. They're not going to mince words. So open your mind. Be ready to change the way that you're approaching your patch. But that can be a really useful tool too. OK, we are reviewing. We found somebody. Somebody's interested. Somebody left their first review finally. I have so many comments. I have 5 comments about why is the change here. I have 15 comments about aligning with coding style. I'm supposed to add tests. Also, I have to split it into 3 more commits. This is going to be a whole thing. So I do it, right? I go through it. I update my code. I answer the comments. And then I have to wait for another round, like days, right? So time zone difference, reviewer dedication, these are things that introduce lag into projects. Your team at work probably has assurance about time zones. Open source projects do not. Some reviewers are probably doing this project as their hobby and not as their job. So maybe they don't have time. Or maybe the project is their job, but your feature isn't a priority for them. And I was just also in a talk this week where somebody said, how many of your managers have asked you to review more code? It was like dead silence, right? For reviewers, it can be really difficult to consistently find time to spend on reviews. And even in ideal circumstances, so maybe whoever does have time to review this change is not actually familiar with this part of the code base. In legacy projects especially, or projects where maintainership has changed hands, it's really likely that nobody knows how all of it works. So maintainers have like an educated intuition, they know how things work at the high level, but if there's a new feature touching a piece of code that they haven't worked with themselves, that's going to be a really demanding review for them. It's going to take them more time and effort to review that. Put yourself in their shoes. It's easiest to review code that somebody else wrote when it's something that you could have written, but you didn't have the time, right? And if you're asking them to do something they didn't know how to write, then it's going to be tricky. So having patience, having grace, this is important. But you also need to understand that the only person's time that you do really have control over is your own time. So you might need to take on more work that you might usually expect the reviewer to do. So stuff like finding prior art in the code base, verifying portability, maybe other kind of researchy stuff. Ideally, a time-strapped reviewer is going to actually give you this homework explicitly, but not always, right? Sometimes they don't realize that that's even an option, and they don't ask. But your patch would go faster if you took on that homework and said like, oh, and by the way, I ran these tests on it, and the benchmark goes like this, and it works on these platforms. That helps, right? OK, so I've had these little sticky notes in the corner for like these maintainer callouts. Usually I've just been letting them go. It's fine. This one I do want to expand on. It sounds ridiculous, but I will say that when I worked on the OpenBMC project, I actually did allocate 1 hour at the end of every workday for code reviews. I did use Garrett, which made it super easy to do that. So maintainers, if this is something that seems like it could work, maybe just check if your tooling would support that kind of thing. And if it doesn't, like maybe should it? Should you get tooling that does work for that? Just a thought. It is feasible to do it that way. OK. Inside Google, we conclude all of our code reviews by saying LGTM. This means it looks good to me. It does not mean, it implies, I believe you know what you're doing. I don't see anything obviously wrong. It does not mean I certify that this change is correct. We don't do that. Because within Google, for our internal projects, undo is super, super easy for us. We have infrastructure for fast rollbacks and reverts. We have site reliability engineers who notice that we broke stuff. We have global incident trackers. We have a culture of accepting that sometimes things that are intended for Googler use will break. Please don't confuse this with our external product reliability stuff. I haven't worked on that. It's a different story. I'm not saying we break our real users all the time. Upstream maintainers, they want to make a really solid guarantee. The goal for an open source review is to say, I'm convinced that this is good. I'm convinced there's no regressions. There's no edge cases or subtleties. We got everything. Maintainers care a lot about user trust. Rollbacks are hard when your release process involves a bunch of distros picking up your package. ABI and API compatibility is really, really important when you can't just go into the mono repo and change all the instances of somebody using your API. This is something we take for granted at Google. Open source projects will support lots of platforms, sometimes really weird platforms, and they will add long-term support for old releases and backport bug fixes when they can. So for you want to add a feature, you want to get on with your life. But for the maintainer, they have to maintain the code base for years to come. And they also want to grow the skill of their project members. So a maintainer's life is going to be easier the more qualified and active contributors they have. And those contributors are going to need less time for their patches, and they can review other people's patches. It really makes the maintainer's life a lot easier. So the maintainer is probably going to guide you to the correct answer instead of just giving it to you. So that'll take a little less of their time, and it will help you grow into a more mature contributor. So all of this stuff is going to compound together into this time lag that I mentioned on the last slide. So you want to just be proactive. You want to have answers for concerns that are likely to come up already waiting. And if you do get feedback from the maintainer that you don't understand or that you don't know how to respond to, ask for clarification. If the maintainer says, this isn't platform compatible, you don't have to say, oh, okay. You can say, do you have an example of other places where somebody made this same compatibility problem and how they fixed it? It's okay. You can do that, right? Here's another really common problem for internal developers. Why are you, this highly experienced senior internal developer, making a change on an open source project in the first place? Could it be because you need to enable an internal feature that's confidential? When you're developing internally, your team knows about the confidential feature. If you need changes in a dependency, you read them into the confidential thing, you share the docs, it's not a big deal. But upstream, you can't do that. So you can't mention what your project is, you can't mention maybe that there even is a project, but you still have to figure out how to justify your change, and you don't want to be cryptic about it. Your upstream changes need to make sense by themselves. So if you're abstracting or generalizing part of the code so that it's easier for you to plug in something else internally, you can justify that refactor by making sure that the resulting code makes sense, maybe makes more sense, and that it benefits the project. Maybe it's easier to test, maybe it has better readability, better documentation, something like this. If you're fixing a pain point or an edge case, those are going to have benefit upstream, but it's not going to be the specific benefit that you're looking for downstream. So you want to use a little bit more general terms. So instead of saying, we're making a VFS that solves XYZ problem, and we're implementing it like ABC. Also, it's due next quarter, so please land it now. Try maybe saying, someone using a VFS would run into this problem. Stick with this kind of generalization. Think about all the people who would be using that bug fix. If you can make one, it really helps to come up with a toy example demonstrating the thing that's the problem. These are really good for complex bugs in any situation, but they also work really well if you're trying to obscure a confidential use case. What you can't do is say, trust me, I need it, I can't say why. That's not going to be convincing, right? As long as nobody's getting paid from your company, they don't care. Okay, so upstream projects are as motivated as internal projects to release new features and bug fixes, but they're going to do that on their own rhythm. Like I said a couple slides ago, the release schedule for a project, it's not going to be the same as your quarterly or your sprint planning cycle. These projects, some are version-oriented, so we're working on 2.3, we have a list of features. When all these features are done, we're going to cut. Sometimes they'll be time-oriented, so every 3 months we're going to cut a release, and if it's done, it goes in. Because of these release cycles, sometimes projects might not want to merge your entire feature at once, or sorry, they might, yes, want to merge your entire feature. They might not want to merge half of it now and half of it next release. Maybe not. It depends on the maintainer, it depends on the project, you can ask. But in the end, your company's deadline, again, does not mean anything to the external project. They're not getting paid by you guys. They don't work there. You can still mention that you have a deadline, and maybe that gets you some sympathy reviews, but it's not gonna like move the release date. So the usual workaround here is to take patches internally before they've been formally released upstream. This is what we do at Google a lot. You have to be careful. You have to only take this, like the best way is to take stuff after it's already reviewed. Because if you take a patch that's still in the middle of review, and maybe that patch modifies a public API, and all of your internal users are using your new public API, and then your reviewers say, hey, your public API could be better if it did this thing, you're gonna have to migrate all your users. That sucks. It's really easiest to patch downstream only when the review is complete and all you're waiting on is the release time. Another thing that you could do is convince your company that releases are for nerds and that you should really be using a pre-release branch. We do this at Google. You may not know that the Google populace is one of the largest set of guinea pigs for upcoming Git features. We actually feed all of our Googlers the next branch, which is the has passed review, is waiting to go into master and then into, like, it's kind of the pre-stable, I guess, branch. So we actually pick up changes to next the second they hit the branch, the hour that they hit the branch, and then we ship them over a 4-day canary. So we usually have our patches, once they land, they're in all Googlers' machines within like a week. So okay, you got your code in, it's done, right? That's great. You should celebrate, first of all. Remember to celebrate, feel proud of yourself, that's awesome. Your code is out in the world, it's helping others, it's helping you, you can build on it, it's great. Now you have experience. You can choose to use that experience or not. It's okay, either way. You could continue to review changes that others make to the code that you wrote or near the code that you wrote, especially if you were working in this neglected area that the maintainer doesn't really know. Now you're like the expert on it. That expertise really helps. Do you remember earlier when I was like, you could ask somebody else at your company to be a mentor? Guess what? So now you can be that mentor for somebody else. And this is really great. This helps the project out. You don't even necessarily have to mentor people at your company. You could mentor anybody. Why not? It's also often pretty valuable to your company to have somebody clued in to what's going on in the project, watching for relevant changes or issues that are coming in. A thing that happens a lot at Google is that we will notice a bug internally with our users, and it'll sound kind of familiar because we saw it being discussed in the open source project on the list, or vice versa, right? Like we'll see something that are, on the list and say, oh yeah, we saw that inside, right? So sharing this experience back and forth, it's great for both sides. All of that setup work that you did that was really hard and slow, you only have to do it once, right? You can carry over all of that setup work to your next contribution, and it's gonna make your next contribution easier. The more you contribute, the more your reputation grows, the easier it's gonna get. So it's really a pretty good investment of your time to stick around. But I will say that contributing to a project does not tie you to that project forever. If you just wanna drop your one-off change and move on, that's okay, you can. You might still get emails about it because now your email is in the commit log. If somebody emails you a question, please don't ghost them. Please reply and say, oh, I'm sorry, I've moved on, I can't help you. Please don't just ghost them, right? You don't want people waiting around. Remember how you had to wait around. You don't want them to wait around for you. So let me pull it all back together and summarize. The technical part, it's only the beginning. Processes that are new exist for a reason. Think about what that reason could be. It helps to view visiting a new project like visiting a foreign country. Be open to a different way of operating. It's not wrong or worse, it's just different. The project is still gonna be around long after you move on. That's what maintainers are planning for. And when in doubt, remember that you can rely on human help. Software development is an inherently human activity, even if some people get help from Copilot. Talk to others like you interact, talk to others that you interact with as though they're humans with respect, and you're gonna go really far. I think I have 2 minutes or 5 minutes for questions. I'm not sure. 2 minutes? The guy in the back tells me. 2 minutes for questions. The URL with the slides, speaker notes, appendix, there's some helpful links. If you ask questions in the comments, we can answer And if you ask questions in the next 1 minute, I can also answer. Any questions? Yeah?
Back to the commit message. I looked at that and I saw a wall of text. Why is that considered a good commit message?
Yeah, so the question was, why did I write a novel and why is a novel good? So let me go back to the commit message just a little bit. So this novel is explaining how we encountered the problem, what the impetus is for the problem, what the code base was doing before, and what we want the code base to do now. It does not describe the diff. It describes the reason that you made the diff. And sometimes that reason takes a lot of explaining. Like, so in the Git project, I've seen commit messages that have like output from hyperfine, or like multiple instances of output from hyperfine, or log dumps, or anything like this. Like it's because 5 years later, when I'm doing like a git bisect to figure out why the commit that I wrote was bad or why it did something a certain way, it really helps to be able to see the whole story in the commit message without me having to say, okay, this was commit called log parent process name. I'm going to copy and paste this into lore.kernel.org and figure out what the conversation was around that. Like, that's slow. Looking at this in your commit history, it's fast. So that's why. It's because we're giving the tools for when we want to look later. Other question? Does that answer your question, first of all?
I don't fully agree with that.
That's fair. Different projects have different standards too. This is the Git standard. It's not the case for all projects, but I also think it's a good, I worked there for 5 years. I'm biased. Okay, other questions? Yeah?
Building on that, you say your commit message, you want to have a cohesive context around it so that it's better for future review. Is that what the meaning of having that much text?
Yeah, so the question is that much text there to build context for future review? Is it for, like, that's kind of your question, right? So yes, it's for future review. It's for people who are reviewing your code before it goes in. It's for, yeah, mostly those two cases, yeah. It can really help out your reviewers right now. Like I said, this is all they get of why you want to do it. That particular example came out of like a post-mortem and a bunch of like conversations within Google and a big like list of action items out of an incident that we had, and like that's it's hard to describe that to the open source. Like they don't have all that stuff that we had, so we had to be pretty verbose. Okay, I think I'm at time, overtime. I'm sorry. Thanks everybody.